Okay, guys, welcome back. We're going into section 3.2 today. We're going to be solving some equations here. So in my first lesson, I'm going to be able to prepare you how to do assignment 3.2, the beginning problems in it from 3 to 16 here. So we're going to be solving quadratic equations. Now we're going to use a little bit of different terminology today. The first one being zeros of a function. And what a zero is the number in which a graph would cross the x-axis, so also known as an x-intercept. An input x value, a zero of a function is an input or x value for which a function's output y value is 0 is called a zero of the function. So as I said before, it's essentially an x-intercept. Now, in general, a linear function, f of x equals mx plus b, it forms a straight line. Typically, it would have only one zero. So I'm going to show you how to find the zero of f of x equals 2x minus 4. So what you do is you take the f of x and you make it into 0. And then we're pretty much just solving this for x. We would add 4 to both sides. And then we would divide by 2. So we would say the 0 is x equals 2. In other words, if we were to graph this thing, what it would be is the line would cross at 2. It would cross the x-axis at 2. All right, so quadratic functions are functions that have an exponent of 2. They can, actually, you can see here in the box, it says the standard form of a quadratic function is f of x equals ax squared plus bx plus c. And when we graph them, they would form a parabola. So again, anything that has an exponent of 2 is a quadratic, and it would form a parabola. Now, the solutions, again, to a quadratic function are its zeros. Sometimes we call them its roots. So you'll hear me kind of interchangeably back and forth calling things, sometimes I call them zeros, sometimes I call them roots. They're the same words, synonyms. So zeros, now this is a major important thing here. Zeros can be real or imaginary. You'll see that pop up in the assignment. So here's 3 examples here. The first one, if we get x equals 2 distinct numbers, we have 2 different zeros. That means the parabola would cross the x-axis in 2 different spots. One real zero would mean it would just touch it in one spot. It's not exactly crossing over. And then the third case would be no real zeros. That means we would have imaginary numbers in our solutions. Again, you'll see that in our upcoming assignment. So now, this can be a pretty tricky section here. It involves stuff that you've done in Algebra 1 and Algebra 2. You can solve quadratic equations or find the zeros of functions by, 1, either you can factor, or you can take the square root if you have an x squared problem without an x. I'll show you how to do that. You can also use the quadratic formula. You'll learn that in part 2. For completing a square, you'll also learn that in the part 2, where we also use the quadratic formula. And number 5, we won't do this one, though, using the graphing calculator. So example 1, we're going to learn how to solve by factoring. So in order to solve by factoring, we must set the equation equal to 0. So we first need to add 6 to both sides. And then notice it's a trinomial, quadratic trinomial in standard form. So to factor, there is no GCF here. So I can go right to 2 parentheses. The x squared gets split up into x and x. The signs are easy here, plus and minus. If you ever need to recap your signs, you can just do a quick Google search, signs for factoring, or signs when factoring. These are obviously all plus, so it's nice, easy, plus, plus. Now remember the rule here is we use the phrase, we need two numbers that multiply to get C and add up to get B. So we need to think of two numbers that multiply to get 6 and add up to get 5. Those two numbers are 2 and 3. Again here, you need to do some mental math. You cannot, I see people all the time just put like 5 and 6 or 6 and 1. You know, stuff that doesn't meet that criteria. So 2 times 3 is 6 and 2 plus 3 is 5. So this is completely factored. I don't have any more exponents. So that means at this point, I'm allowed to go ahead and find out what my zeros are. So what I do, I just make two little mini equations. I take each factor and I set it up equal to 0. And then I solve them. The first one we would subtract 2. So we have my first 0 being -2. And the second one we would subtract 3 from both sides. So we get 2 roots in this problem, -2 and -3. Okay, let's try another one. If you scroll down to assignment 3.2, I'll do number 4 for you. So this guy is set equal to 0, so it can be factored now. I don't have a GCF. It's pretty easy trinomial here, so I'm going to go into 2 parentheses. The x squared gets split up into x and x. The signs are pretty easy. It's all plus. And we need two numbers that multiply to get 8 and add up to get 6. 2 and 4. 2 times 4 is 8. 2 plus 4 is 6. So it's factored, so I can now go ahead and find out what my two roots are. So I set each factor equal to 0. And now I'm going to solve. My first one, I would subtract 2. So I get -2. My second one, I subtract 4. So I get -4. Scroll back up. All right, now let's go back to example 1, solve by factoring. Let's try letter B. So again, here I'm going to solve by factoring. When you want to solve by factoring, you've got to set it equal to 0. So we need to subtract 3x to make it equal to 0. All right, so now I'm going to try to factor this. I do have a GCF here. It's x. So I pull out an x, and then I divide each of them by x. So I have 2x squared minus x to the power of 1 minus 3. All right, it gets a little tricky here because of that 2 out in front of the x squared. It is not easy to factor here. So I'll help you out a little bit. So let's break this up into 2 parentheses. Don't forget to bring down the x out in front from your GCF. Now my signs here have to be, remember we looked at the C term first. When the C term is a minus, your signs have to be plus minus. And we're going to use the guess and check method. If you need to watch any further videos on, say, YouTube, just go into YouTube and type in factoring trinomials guess and check. So we look at the 2x squared. Some possibilities are to put, of 2 would be 2x and 1x. And then factors of 3, I can try 1 then 3 or 3 then 1. So let's try 1, then 3. Now let's do our check here. Remember, to do the check, you multiply the outsides. That would get negative 5x. Then you multiply the insides, and that would be plus 1x. They unfortunately add up to get negative 4x. We need them to add up to get negative 1. So that means 1 plus 1 then minus 3 wouldn't work. So let's try to switch them up. Let's try 3 then 1. Check outsides, multiply, and then insides, multiply, and those add up to positive 1x. But we need it to add up to negative 1x. So what I usually tell people, if we're this close but the sign's off, just try to change the signs. Instead of plus minus, now let's try minus plus. Now we're going to test it out. Outside multiplies to get 2x. Inside multiplies to get negative 3x. And they add up to negative 1x. I'm good now. That means my check is good. So let's get rid of this work, clean it up a bit, and now this thing is fully factored. So now I'm going to go ahead and get my answers. I'm actually going to get 3 of them. Your first answer comes from the first x out in front, x equals 0. Now let's get your second answer. That comes from the 2x minus 3 equals 0. We would add 3 to both sides and then divide by 2 to get x equals 1.5. So there's my second 0 or root. And then the third one, x plus 1 equals 0. Subtract 1 from both sides, and you get x is negative 1. So there's your 3 answers. Yes, that was very challenging. That's as tough as this section is going to get. Just make sure, if you can't get that hard stuff down, don't sweat it too much. Just make sure you're getting the easier stuff down first. Okay, the next method in example 2 is called the square root method. We're going to solve this equation by the square root method. We cannot do this method every single time. We can only do it when it's missing an x term. Notice this equation has an x squared term, and it has a constant, the minus 10, but it's missing the bx term. So we are allowed to solve it by the square root method. So what we're going to do is we're going to get x squared by itself. We want to get x squared equals a constant, and then we want to square root. So the first thing I need to do to get x squared by itself is to add 10 to both sides. Then after that, I'm still working on getting x squared by itself. I have that 2 out in front, so I need to divide both sides by 2. So now it shows x squared equals 5. I have x squared by itself finally. It's in that form, x squared equals c that I mentioned. Now, you don't have you're not done yet. You still have an exponent of 2. And in order to get rid of an exponent of 2, you square root both sides. So that cancels the exponent, bringing down x by itself. And then you put a plus minus in front, and then you try to simplify the radical. The square root of 5, however, cannot be simplified. And just a heads up, we do not want decimal form. All of our answers must be in the simplest radical form. Now, we do have 2 answers here, just a heads up. This is where the plus minus comes from. We have 2 answers. The answers are square root of 5 and negative square root of 5. Okay, let's try another one below. Scroll down to the assignment. I'm going to help you out with number 10. So again, I see that it's missing the bx term, so that means I can go ahead and solve by square rooting, the square root method. So I need to get x squared by itself before I square root. So I'm going to add 20 to both sides. Then I need to divide both sides by 2. Now, x squared is by itself, so now I want to take the square root of both sides to get rid of the exponent. So I'll have x equals, put a plus minus in front, and then the square root of 10. Now, I do try to break down the radical. 10 breaks down into 2 times 5. However, there's no 2 of a kind to come outside of the radical. So 10 is stuck inside the radical. So I have my 2 answers here. My 2 answers are square root of 10 and negative square root of 10. Again, keep it in radical form. Do not turn it into a decimal. All right, let's go back up. And let's solve this equation by factoring. So, actually, hold on. Before I do that, let's scroll back down. I want to do number 13. So this one, again, I can solve by square roots. So, again, I'm missing the bx term. So let's get x squared by itself. So we're going to subtract 16. And then x squared is by itself, so I can take the square root of both sides. So it'll cancel the x squared, so x equals, make sure you put in your plus minus, and the square root of negative 16 is 4i. Remember, we have a negative inside the radical. That means you must pull out an I. So my 2 answers are 4i and negative 4i. So, as I said way back in the beginning of today's lesson, that sometimes we won't get real answers. In this case, we have 2 imaginary solutions. What would this look like if we were to graph it? It would just be a parabola that would never cross the x-axis. All right, let's go up and do the last one up here. The last one for my lesson today. Example 3. We're going to solve this equation by factoring. Again, notice I cannot do the square root method because I have an x term here. So we got to think back to factoring. Now factoring, again, we want it to be equal to 0. So let's subtract 14x to move it over to the left side. They are not like terms. Please keep those terms separate. Now, to factor this is the second one today where we actually have a GCF. The GCF of 7 and 14 is 7. But both terms also have x's. So it's going to be 7x is the GCF. Remember, the rule for variables is you choose the smallest exponent. This guy had a 1, so my GCF has a 1. So now we need to divide by the GCF that we took out. Remember, GCF or factoring is dividing. So 7x to the second divided by 7x to the first is 1x minus 14x divided by 7x. The x is canceled, and that would just be 2. So now this is factored. I can now get my answers, also known as my roots, also known as my zeros. So I can do 7x equals 0 and x minus 2 equals 0. The first one you would divide by 7 to have 0. And the second one you would add 2 to get x is 2. So again, I got 2 zeros here. That means this would be a parabola that would cross the x-axis twice at the points 0 and 2. Okay, guys, I've now prepared you. You should be good to go on assignment 3.2. You should be able to finish up the problems that I didn't do. It's only like 9 or 10 problems.